The transformation from the logical model to the physical model is straightforward. From the logical model, you have all the relations and associations you need to create a database. The table shows the correspondence between conceptual, logical, and physical model concepts. All you have to do now is specify the subdomain or the data type for every attribute domain you encounter within every table and the corresponding constraint. From the logical point of view, you may see a database as a container having a lot of objects. Logical database design consists of defining database objects. The following database objects can be created within a DB2 database: tables, constraints, indexes, triggers, sequences, and views. These database objects can be created using graphical user interfaces or by explicitly executing statements. The statements used to create these database objects are called data definition language and are generally prefixed by the keywords create or alter. From the physical point of view, you may see a database as a set of directories and files. In the path you specify while creating a database, a subdirectory in the name of the instance is created. Below the instance name subdirectory, a subdirectory named node 0000 is created. This subdirectory differentiates database partitions in a logically partitioned database environment. Below the node name directory, a subdirectory named SQL 00001 is created. This contains objects associated with the first database created, and subsequent databases are given higher numbers. For example, SQL 00002 and so on. SQL, Structured Query Language. This is the standard relational database language. SQL is a high-level language that allows users to manipulate relational data. One of the strengths of SQL is that users need only specify the information they need without having to know how to retrieve it. The database management system is responsible for developing the access paths needed to retrieve the data. SQL works at a set level, meaning that it is designed to retrieve rows of one or more tables. SQL has three categories based on the functionality involved: DDL, Data Definition Language, used to define, change, or drop database objects; DML, Data Manipulation Language, used to read and modify data; DCL, Data Control Language, used to grant and revoke authorizations. When you create a database, information about the database, including default information, is stored in a directory hierarchy. The hierarchical directory structure is created for you at a location that is determined by the information you provide in the create database command. Just in the same way we store and manage data files on a computer in directories or folders and keep related files together, a schema in DB2 is a database object that allows you to group related database objects together. In DB2, every object has two parts: a schema name and the name of the object. To create a schema, we use the statement create schema my schema. You can use IBM Data Studio tool to create a schema within a DB2 database, like we have shown here. When the schema is not specified, DB2 uses an implicit schema, which is typically the user ID used to connect to the database. You can also change the implicit schema for your current session with the set current schema. A table is a data set organized and stored in rows and columns. A table holds data for like items, for example students, professors, subjects, books, etc. As you saw in the beginning, entities in a data model maps to tables when implemented in databases, and attributes of entities map to columns of the table. Let's start creating a simple table with the least amount of information required. For example, create table, my table, call one integer. The statement creates a table with the name my table, having one column with the name call one that can store data of type integer. This table will accept any integer or null value as a valid value for call one. You can also create a table using command editor within DB2 Database Management System or using IBM Data Studio tool. This slide shows you the Data Studio snapshot. A null represents an unknown state. For example, a table that stores the course marks of students can allow for null values. This could mean to the teacher that the student did not submit an assignment or did not take an exam. It is different from a mark of 0, where a student did take the exam but failed on all the questions. There are situations when you don't want a null to be allowed. For example, if the country field is required for your application, ensure you prevent null values, and it can be done as follows. Create table my table, name varchar of 30, country varchar of 20, not null. The statement above indicates that null values are not allowed for the country column. However, duplicate values are accepted. When data is inserted into a table, you may want to automatically generate default values for a few columns. For example, when users of your website register to your site, if they leave the profession field empty, the corresponding column in the users table defaults to student. This can be achieved with the following statement. Create table users, name char of 20, age integer, profession varchar of 30 with default student. Constraints allow you to define rules for the data in your table. Following are the different types of constraints. Suggest you to have similar suffixes for constraint names for easy identification. A unique constraint prevents duplicate values in a table. This is implemented using unique indexes and is specified in the create table statement using the keyword unique. A null is part of the unique data values domain. A primary key constraint is similar to your unique constraint. However, it excludes null as valid data. Primary keys always have an index associated with it. A referential constraint is used to support referential integrity, which allows you to manage relationships between tables. A check constraint ensures the values you enter into a column are within the rules specified in the constraint. The following example shows a table definition with several check constraints and a primary key defined. Create table employee, ID integer, not null constraint, ID pk primary key, name varchar of 9, department small in constraint department ck, check, department between 10 and 100, and so on. For this table, 4 constraints should be satisfied before any data can be inserted into the table. These constraints are primary key constraint on the column ID. This means that no duplicate values or nulls can be inserted. Check constraint on department column only allows to insert data if the values are between 10 and 100. Check constraint on job column only allows to insert data if the values are sales, manager or clerk. Check constraint on the combination of the hire date and salary columns only allows to insert data if the hire date year is greater than 1986 and the salary is greater than 4500. Referential integrity establishes relationships between tables. Using a combination of primary keys and foreign keys, it can enforce the validity of your data. Referential integrity reduces application code complexity by eliminating the need to place data level referential validation at the application level. A table whose column values depend on the values of other tables is called dependent or child table. And a table that is being referenced is called the base or parent table. Only tables that have columns defined as unique or primary key can be referenced in other tables as foreign keys for referential integrity. Here is another example for referential integrity. In the above example, when the constraint name is not specified, the DB2 system will generate the name automatically. This generated string is 15 characters long. A view is a virtual table derived from one or more tables or other views. It is virtual because it does not contain any data, but a definition of a table based on the result of a select statement. For example, to create a view based on the employee table, you can do create view my view as select last name hire date from employee. Once the view is created, you can use it just like any table. For example, you can issue a simple select statement as follows. Select star from my view. Views allow you to hide data or limit access to a select number of columns. Therefore, they can also be used for security purposes. Once a database object is created, it may be necessary to change its properties to suit changing business requirements. Dropping and recreating the object is one way to achieve this modification. However, dropping the object has severe side effects. A better way to modify database objects is to use the alter SQL statement. For example, assuming you would like to change a table definition so that nulls are not allowed for a given column, you can try this SQL statement. Alter table my table, alter column col1 set not null. Similarly, other modifications to the table like adding or dropping a column, defining or dropping a primary key, and so on can be achieved using the appropriate alter table syntax. The alter statement can also be used with other database objects. Apart from modifying the existing database objects, they can also be renamed using the SQL statement rename. To rename any database object, use the following SQL syntax. Rename object type, object name, this is existing object name, to new name, where the object type can be, for example, a table, table space, or index. Note that not all database objects can be renamed after they are created. To rename a column, the alter table SQL statement should be used in conjunction with rename. For example, alter table, table name, rename column, column name to new name.